All right. Assalamu alaikum all. Am I audible?
Alaikum salam, ma'am. Yes, ma'am.
So I'll not take the test today because some of the students had requested not to take it today as you needed some more time for preparation. So this is Wednesday. So on Monday, we will have the test of circular motion. So if you all have any doubts on that topic, so you can send me the questions also on WhatsApp. We'll have a doubt class as well. And Abdullah, I wanted to talk to you. Is your number now added on the group? The number which you had sent? Because I wanted to arrange a doubt class with you. You were having certain issues, so I wanted the questions so I could send you on WhatsApp. But I couldn't find your number. That's why I'm asking you. If it is there, just let me know because I want to get it updated. Otherwise, this will become very difficult for us to tackle all this. Now, see, we had started with work done. Let's complete with it. See, the class of this differentiation and integration calculus is becoming difficult. So what we'll do, as the question will come, then and there only. Group, no, still not your added group, the WhatsApp group which is there. A WhatsApp group is there for boys and girls separately for both class 11th batches and class 12th batches. So if you're not added on the group, okay, just check. Let me know. All those who are not added, I'll get you added because sometimes it happens the class gets delayed. If it happens, though it has not happened yet, but if the class gets delayed, the class is not there, yet the test papers that you will send, some information if I have, there is, we share it on the group only and it becomes a connecting basis. So if you, and you can take my number also from the group only. My WhatsApp number is there. All right, so let's complete with this work. At least we should complete work energy theorem today because work energy theorem is very important. You see, this book, no, that is the first book of your class 11. This is the basic for physics. Maximum questions that will be asked to you will be direct in the question, but you won't realize after the topics will get piled up, after your class 11 gets over. Okay, Yusuf, is this the same number in which you get the link ID for the classes? If this is the same number, then I'll refer it directly.
Yes, ma'am.
It's the same one? Okay, Yusuf. Then it's fine. I'll just take your name. So, for example, work energy theorem that we see, or any, like this work done only, or centripetal force we had studied. That is a part of your class 11. So in class 11, you'll be having questions sticking to this only. But when you'll go to class 12 or any other topic that you're covering, you will see things will get related to this. A force will be there. Electrostatic force will be providing necessary centripetal force for a charge. So what will you do at that time? So most of the basic things have to be covered right now. That's why these chapters are taking time as well. And your syllabus, class 11 syllabus is also huge. But sooner you will be having the duration of class more because in this 1.5 hours duration, we'll not be able to complete with the syllabus, no, but tests and numericals practicing and revision. So once let the 12th class batches have their syllabus over, most probably by 15 November or so, end of November, they will be having their whole class 12 board exam syllabus complete. So your timings will increase accordingly to your batches, whatever you have. So work done we had started. Work done is basically dot product of force and displacement. So your aim will be dot product of force and displacement in any way it is given, whether it's constant, whether it's variable. So it's a scalar quantity whose SI unit is joule, CGS unit is erg, and 1 joule is equal to 10 to the power 7 erg. This much we have completed and we were doing questions. So this was a very basic question. This involved a little of Cartesian plane. So now let me give you a question that will involve integration because differentiation won't be applicable here. Because since it is becoming very difficult as you all have your mathematics class on Saturday and Sunday. And rest of the weekend, the batches are completely full. Your 12th class batches are also there. So that's why it becomes difficult. So we'll try to learn it here only. A second, this will be third question. See, let's say force is given as 3x square plus 2x. This much Newton. I think this is sufficient for the practicing part. This much force is given. So all those who are weak at calculus, try to listen and focus here, because now these things will be related to your integration directly. So this much force acts on a body. Body. So calculate the work done. X equal to 0 to x equal to 2 meters. So right now in this lesson, I think for some parts we'll be able to do only integration. So let us at least complete with integration. See, work done is what? Work done is f dot dx from x1 to x2 for a variable force. Okay, since we didn't do integration, that's why I didn't write it on that class. And if it's a constant force, you write here only, I'll write work done is f dot x. This is only if the force is constant. Fine. So this is for a constant force and this is for a variable force. So right now your force is what? Your force is given as 3x square plus 2x. All right, this is the force that is given. So if I change the value of x, if I write x as 1, so value of force will be what? Value of force will be 5. If I change x's value as 2, will it be still 5? No, the value of force will differ now. It will become 3 into 5 square plus 2 into 5 like this. If I change the value of x to 3 or x to 0, force will become 0. It means this is a variable force. Whatever value of x you put, the value of force you get. But if I say force is 5 Newton, so at t is equal to 0, force is 5 Newton, at t is equal to 100 seconds, force is 5 Newton. That means that's a constant force. This is the difference between constant and variable force. You have to see the independent and dependent variables. If your force and your displacement or any quantity, here displacement is given, otherwise it could have been time, any quantity, your one quantity is depending upon the other quantity, right? If your one of the quantities are depending upon the other quantities, then you say, all right, then you say your other quantity is variable, right? Otherwise, if it is not changing, whatever be the value, if it is not changing, it is constant. So here we can clearly see force is variable. So we'll integrate it. So work done will be f dot dx. F is 3x square plus 2x. This term dx, and limits are mentioned in the question from x equal to 0 to x equal to 2. Right? So this is basically two sets of integration which you are adding up. One set is to integrate 3x square, other set is to integrate 2x. It means 3x square dx you are integrating from 0 to 2, plus you are integrating 2x dx from 0 to 2. Now basic rule of integration that will be required over here and everywhere. Some x has power n, and I'm differentiating x and dx. So not differentiating, integrating. All right, I am integrating this. So when you integrate, x to the power n is there. Keep x to the power n as it is. Listen here carefully, class. 1 in the numerator. Right? Add 1 in the numerator. When you add 1 in the numerator, whatever, not in the numerator, actually in the power of the numerator, whatever exponential or whatever power you get it, write it as it is in the denominator. This is integration of x. X to the power 2, for example. Keep x to the power 2 as it is. First step, write plus 1 in the power of numerator. What are you getting? 2 plus 1, right? 2 plus 1. So what is there? X to the power 3 divided by 3. Right? And whenever a constant term is there, multiply that constant term with your answer. For example, let's say it was some constant kxn. So xn, you know, x to the power n, how to integrate? Just multiply k at the end. So that becomes kxn here. Let's say x to the power 2 is there. Some constant is there. Let's say not k, let's say it is 4. 4 is a constant number. So at the end, just multiply 4. That will be your answer. All right, this is the basic steps. These are the basic steps that are required by all of you. Now see, 3x squared limit, I will let you know right now how to substitute the limit as well. But solving this is important. See, now you are integrating 3x square. So keep 3 aside, 3 will multiply it x square. Yusuf, what should be the steps now for x to the power 2? What we'll do, first thing that we do, x to the power 2.
X to the power 2 plus 1
Hmm.
divided by 2 plus 1.
2 plus 1. Perfect. Perfect. And what about the constant term? We just multiply the constant term. So this is having the limits from 0 to 2. Plus 2 is a constant, only x to the power nothing, 1 is given. So Tarif, how we'll do it? X to the power 1 is here, no power.
Yes, Miss X. Then plus 1 by
Plus 1 divided by
1 plus 1.
1
2
plus
plus
1. 1 plus 1.
plus 1.
Whatever is the power, 1 plus 1. And this is a constant term, so we multiply this constant term as it is. Limits are 0 to 2. Now let's write this, then we'll focus on the limits part. So this is what? This is basically 3x to the power 3 divided by 3 from 0 to 2 plus this is 2x to the power 2 divided by 2 from 0 to 2. 3 gets cancelled, 2 gets cancelled. Now see, for the limits, take the upper limit, put it in the value of the variable as it is. Like it is, let's say x to the power 2, limits are x1 to x2. So take x2 instead of x and take whatever is the power obtained now, minus lower limit to whatever is the power obtained. For example, in this part, this is x to the power 3. So upper limit is 2, so that becomes 2 to the power 3. Minus lower limit is 0. So 0 instead of x and power 3. Plus, come to this term. This is x to the power 2. So upper limit 2 to the power 2 minus lower limit 0 to the power 2. This is how we write it. So we have come to the answer. This is 8, right? Minus 0 is 0 plus 4. So that is 12 joules. This is the answer. All right, like this we integrate and like this we solve the questions of work done as well. Note this down, this question. Then let's see certain graphs also in your syllabus and especially in some school exams, graph also come. And Abdullah, just let me know about that WhatsApp thing. Okay, just check and let me know. Yes, Aisha. See, constant and variable force means you have to identify whether a force is variable and constant. The way we had no variable velocity, variable accelerations. So if a force like this, which is written as F is equal to 3x square plus 2x, as you keep on changing the value of x, you'll get different values of F. You change x as 1, you get the force as 5. You change the x values as 0, you get force as 0. So for different values of x, you're getting different values of force. That means it is variable. So whenever you have variable force, that time you integrate it with whatever are the limits provided. Like in this question, it was 0 to 2, like this. And if it's a constant force, like F is equal to 5 Newton, F is equal to 3 Newton, F is equal to 12 Newton, any fixed value of force, F is equal to pi, which is 3.14, that is also constant. Then you use simply F dot x. F dot s, no, the way we have been doing dot product of force and displacement. Same thing. Done, class. Must have completed by now. If anyone is writing, let me know. Otherwise, graphs also we'll do before we start with work energy theorem. Graphs are also very important, and graphical method, I'll write it down as. See, class, one very basic thing for graphs, which is not only valid for this, which is valid for any of the two quantities. If you think two quantities or any one single physical quantity is given by the division of two quantities. For example, velocity is displacement divided by time, or acceleration is velocity divided by time. Anything that gets divided, then you take the slope of the graph. Fine. Then the quantity, no, which is there. For example, this is velocity is equal to displacement divided by time. Acceleration is velocity divided by time. So if I want to know what is velocity using graph, I'll take the slope of the graph. Slope of the graph will give me velocity. If it's x by t graph, I'll get it through the slope. Or it's vt graph, the slope will give me acceleration. Slope means tan theta. Slope is simply tan theta. Graph is there. Let's say this is a graph. So if you take the tan theta of this, whatever is this triangle formed, so that is division. In division, you have the slope of graph. If two quantities are getting multiplied, then your quantity is given by the area under graph. For example, work done. Work done is force multiplied by displacement. So force and displacement which are getting multiplied will give you work done by the area of the graph only. This will be given by the area of the graph only. If it was force divided by displacement, then it would have been given by the slope of the graph, that is tan theta. Whenever slope part will come, that we'll discuss later on. Since in work done, you can identify work done is simply force multiplied by displacement. This is just what we have discussed if two quantities are getting divided and if two quantities are getting multiplied. So if you want to find out work done, then area work done is simply given by area under the graph. So area under the graph means the area of this triangle part that you are obtaining, this triangle part which you are obtaining. This is known as the area under the graph. So remember, for the graph that is above the x-axis, area will be positive, and whatever area you are getting it below the axis, that will be negative. See, that's what I was telling you. Whatever is above the graph, that area will be positive. And area is simple. The way you calculate, the area of a triangle, simply half into base into height. Like that only you have to calculate. Let's do it with the help of one question. At least let's take one question and solve it. So this is the figure given to you. Certain dimensions are there. This is force. This is displacement. This is force. This is 3. This part is -2. It is actually 2, but since it's below the axis, this is negative of y-axis, it will be negative only. This part is 2 meters. Anything else required? Yes, this part is 4 meters. This point is 4 meters. Now see, work done will be what? You have to calculate the work done. That is the question. You have to find out what is the work done. Calculate work done. So work done means area of the first one plus area of the second figure. That will give me the area under this graph. So see, work done will be area of rectangle plus area of triangle. Fine, area of rectangle plus area of triangle, that will be entire work done of this. Clear? Now area of rectangle, this is 3, this, okay, this point is 2, this point is 2, this point is 4. So it means this much is 3 meters and this is 2 meters. So area of triangle is simply 3 into 2 plus area of the this triangle, half into base is 2, 4 minus 2 will give you 2, into height, height is minus 2. This 2 gets cancelled. This becomes 6 minus 2, which is 4 joule. So if you are taking it as 2, then add a negative sign at your own by yourself. If you're not taking it, simply use this negative sign because this triangle will be negative anyway. And this rectangle will be positive because it is lying above the axis. Fine? Clear till here or not? This lesson so far, is it clear to all of you? This is a short lesson and it's easier than your laws of motion and even the next lesson that is coming, rotational physics. This is a short lesson. This won't take so much of classes. It will be over sooner only. So if you practice it well, you will be able to score at this. Test, as I have already announced, I'll take it on Monday. Short test I'll take, but we'll have the classes as well. All right, note it down then. Done? Now we have to start with kinetic energy because your work energy theorem is a very important topic and that is related to your kinetic energy. But before now we directly begin with kinetic energy. Just one thing, class, I hope you're aware of this fact. Mechanical energy is a term. That is the total energy present in your system. Total energy that is present. It can be kinetic energy. I'll be using K and P. That's why I've written it in the bracket. Kinetic energy and potential energy are the two main energies that will be needed by you. All right. Apart from these two, no, there are other energies also present in your system. Internal energies are there. Some energies are there that get cancelled also. So many energies are there. Important ones are kinetic energy and potential energy. So sum of kinetic energy and potential energy is known as, collectively, this is known as mechanical energy. Right now, we'll be focusing on kinetic energy. So kinetic energy, no? Kinetic energy is mainly possessed whenever a body is in motion. Velocity changes, you have an associated kinetic energy. Velocity is present, you have an associated kinetic energy. So this is the energy possessed by a body due to its motion. Energy possessed by a body due to its motion is what is kinetic energy. For example, you have a body whose mass is m and it's moving with a velocity of v. So kinetic energy is given by half mv square. Now, how is it half mv square? That we'll do using our work done only. This derivation comes in your exam. This is just for your class 11th only. Otherwise, this derivation won't be used anywhere. Kinetic energy's formula will help only. So let's say you have some surface you have. On this surface, I have kept a block. Fine, this block. And after some time, this is a block of mass m. Initial velocity is 0. Some force is applied on this mass. So it starts moving. And once it starts moving, then this block of mass m attains a velocity v. So v2 is equal to v. So initially it is at rest. Now it is in motion. Force is for your variable force because we cannot consider that a constant force is applied. We have to take a case where a variable force is there. So for variable force, we have studied that f dot dx from where? 0 to v. This is initial 0. This is final velocity v. So from 0 to v, f dot dx, right? Now, if mass is m and let's say acceleration of the body is a, what will be the force? Theorem. Yes, Theorem?
Sorry, ma'am, could you repeat?
Mass is m, a is acceleration force.
Mass into acceleration, I mean.
Mass into acceleration, m. Put it here. This is class again, I'm telling this won't come as a numerical. Most probably the chances are there this will come as a derivation only in your exam. MEA dx, integrating it from 0 to v. Now see, you cannot, acceleration is not constant, only mass is constant. But acceleration and dx cannot be integrated. You have to have the same quantities. So see, acceleration is dv by dt, right? Acceleration is what? Acceleration is dv by dt. Put it, see, are we getting some like terms or not? 0 to v m into dv over dt into dx. Can any one of you tell me what is dx over dt?
Displacement.
Displacement is dx only. Dx over dt.
Velocity.
Velocity. This is velocity. Good, Aisha. This is dx over dt, which is velocity. So now keep it in this. So this becomes 0 to v, m dv is there, and this becomes v. Now see, you have m dv dot v. Simply you can now integrate v. M is a constant. See, you can write it like this. M is a constant, integrating v from 0 to v. Can you see all the terms are like now? Now you can perform integration. If you had acceleration dot dv, how would you integrate it? And the limits are also of velocity. You cannot integrate it like this. You have to have the same functions. This is not the same function. Acceleration is another variable quantity. Velocity is another variable quantity. So just these extra steps have been done to make this only. Now we have this. So as you have studied, yes, Talha, if v to the power 1 is there, how can I integrate it?
V to the power 1 plus 1 by 1
Yes,
plus 1.
divided by 1 plus 1. Perfect, Talha. Good. So m is a constant term over here. We'll multiply the constant term, limits from 0 to v. This makes it m v to the power 2 divided by 2, 0 to v. So m by 2, upper limit v square, lower limit 0 square. So finally your formula is half m v square. This work done gets stored in the form of kinetic energy. This is work done, not that we are calculating. This work done gets stored in the form of kinetic energy. So that's why you have the formula of kinetic energy as half m v square. Now after this we'll do work energy theorem that will be related to this only. Simple, easy step, nothing, no different derivation you have, same derivation will only be there. Just with a very, very slight difference only. First you note it till now, then I'll let you know. But class, work energy theorem is very important, more than this topic. All right. So that's why I'm continuously telling you so that you have it in your mind. Okay, note this down. Then we'll do work energy theorem. Work energy theorem is simple. When you will hear it, no, you will realize that this is just one liner. All right. See class, work energy theorem also says this only. This statement, no, that you have studied, this one. That work then gets stored in the form of kinetic energy. This is exactly what is work energy theorem. Whatever is the work done, this is equal to change in kinetic energy. This is just a difference in the statement of work energy theorem. I'll do one thing, I'll write it here. Work energy theorem. It says that work done is equal to change in kinetic energy. Whatever is the work done, this is equal to change in kinetic energy. This means in this, the derivation is same, exactly the same derivation is. It means some initial velocity is there of the body, let's say v1, and the final velocity is there v2. This is v1, this is v2. So we'll integrate it from v1 to v2, v1 to v2. So this whole, these all the steps will be the same. When you will come to the limits part, it will be from v1 to v2. This is just the difference that will arise, v1 to v2, v1 to v2. So this becomes v1 square minus v2 square. So this is half m v1 square minus half m v2 square. Or v2, actually v2 square minus v1 square. Upper limit minus lower limit. No? v2 half m v2 square minus half m v1 square. So this is what is your work energy theorem. Total work done is equal to change in kinetic energy. Let's do some, just quickly note this down as you've already written it. So copy it from there quickly. Write down the statement of work energy theorem, mark it as important. Quickly copy it down, just change v0 to v1 and v1 as v2. Quickly. Because let's practice some questions. Some questions are there. Some easy questions are there only, but we have to have a practice of that. Just write it till here only. No need to write this gets stored in the form of kinetic energy because we have already written it. Okay, one type of question no class that you get that connects a relation between your momentum which you studied and kinetic energy. So if you have like percentage change in momentum, it's a percentage change in momentum and is given as 10%. You are asked to calculate the percentage change in kinetic energy. So how will you solve this? See, kinetic energy's one more formula is P square by 2m. P square by 2m. Fine. So using this formula, you will calculate the percentage change in momentum. These kinds of questions also come. That's why I'm writing it separately. For example, kinetic energy first will be P1 square by 2m. Kinetic energy second will be P2 square by 2m. P2 will be P1 plus 10% of P1, right? And this way you can calculate the percentage change in kinetic energy if you have values of P1 and P2. This will be simply kinetic energy second minus kinetic energy first divided by kinetic energy first into 100. Fine. Into the original kinetic energy into 100. Like this. These types of questions also come. These are very easy, just based on this pattern exact. Just you'll be having a change in the magnitude. All right, some questions let's do based on this. Before that, just write it down and we'll do question. Okay, as you all have class only after 10 minutes, let's stop here. Questions we'll do in the next class. So 2 questions are there, then this work energy theorem will be over. And this chapter is anyways a smaller chapter. So we should complete it by next week. So you will be having a test of circular motion on Monday. 2 to 3 questions will be there maximum. Please prepare for it. If you have any doubts, any queries, let me know on WhatsApp. Otherwise, you all can leave so that you get at least 10 minutes break for your next class. Okay, thank you so much, class.